So it's LeetCode problem 643, maximum average subarray 1. So in this problem, okay, so in this problem we are given an integer array called nums and integer number k. Okay, so our task is to find the maximum average of the continuous subarray of the length k. So array means list of the numbers like this. Okay, list of the number, and contiguous means continuous with no gaps. Example, see, gives means 12, 5 and -6. This is contiguous and this is not contiguous, 50. Okay, so this was not contiguous. Okay, so this is contiguous. And subarray means subarray is a continuous part of the array. Okay, so average means all numbers are divided by many numbers there are. So the formula of that is average is equal to sum divided formula is sum divided by count. Okay, now let's understand the problem. We are given nums like this: 1, 12, 5, -6 and 50, 30. Okay, and k is equal to 4. So we must only choose 4 continuous number and find their average. So first let's see our possible subarray of the size of k. First is 1, 12, -5 and -6. So sum of this is 2, and if we do average, 2 divided by 4 is 0.5. Okay, next is, so this is 1, and next is 12, -5, -6 and 50. This is 50. Okay, so the sum of this is 51, and average of this is 51 divided by 4 is 12.75. and next is third, -5, -6, 50 and 3. Sum of this is 42, and average of this is 42 divided by 4 is 10.5. Okay, so the maximum average of this is this. In all of these the maximum average is this, so we need to return this 12.75. okay, so in brute force, take every subarray of size k. Okay, calculate its sum, divide by k to get the average, keep track on the maximum average. So but this take too much time, so for this we are going to use sliding window. Okay, instead of calculating the sum again and again, we use the sliding window technique. So first calculate the sum of the first k element. Okay, first we calculate the sum of the first k element, then this is a first window, then move the window one step at time. When the window move, add the new element, remove the old element, update the maximum sum. Okay, so let's try them on this. If we have nums like 1, 12, -5, -6 and 50 and 3. Okay, k is equal to 4. So the first we calculate the sum of the first k element. So this is the first window is 1, 12, -5 and -6. So the current sum is equal to 2 and max sum is equal to 2. Okay, next we move window. So add 50, we'll add 50 and remove 1. Okay, how it's look like? We add 15 and remove 1. So we add 15, we remove 1. So current sum of this is current sum 2 plus 50 minus 1 is 51. So the max sum is 51. So now we add 3 and remove 12. Okay, we add 3. So we add 3 and remove 12. Remove 12 and we add 3. And we remove 12. Yes, we remove 12 and add 3. How it look like? 51 plus 3 minus 12 is 42. So the sum is 51. The final maximum calculation is maximum average is equal to 51 divided by 4 is equal to 12.75. So this is the how. So that's how it's working. Let's write down the code. First, current sum is equal to 0 and max sum is first step. We calculate the sum of the first k element for I is equal to 0, I is less than k and I plus plus. Current sum plus equal to nums of I, then nums of I minus nums of I minus k. Nums of I so now it's like this. Next will be update of current sum. First we update current sum. Max sum is equal to current sum. Next we slide the window for int. No, for int, yes, for int k I is less than nums dot size plus plus. Now we add new element and remove old element. Current sum plus equal to nums of I minus nums of I minus k. Now we'll update the maximum sum. Max sum equal to max sum comma current sum. Now we just return max sum. We'll divide by k. Yes. Yeah. So the time complexity of this is big of n, and space complexity is big of 1. So we calculate the sum of the first k elements, write the window while updating the sum, drag the maximum sum, and finally divide it by k to get the maximum average. That's all.